Hello everybody and welcome back to AI Blades, bringing you cutting-edge AI security. Today, we're going to be taking a look at Claude computer use, the first prompt injection, and we're going to be answering the question, should we really be letting an AI control our computers? On the 22nd of October 2024, Claude computer use was released to the world. While computer use is an incredible tool, it is also insecure by default. In this blog post, we'll look at how Johan Rehberger from Embrace the Red was able to completely compromise a Claude-controlled machine via an ingenious indirect prompt injection. So, to begin with, how does Claude computer use actually work? Well, this is going to be very high level. I have tested it out myself, but I'm not an engineer of any kind. So at the moment, computer use is only available as a beta release. Computer use has two different components. It has the actual computer, which is controlled, and it has Claude Sonnet attached to this. The computer is a dedicated container or virtual machine pre-configured to be controlled by Sonnet. When a user puts a query into Sonnet, the LLM carries out these instructions on the computer. Sonnet receives multiple screenshots from the computer as it carries out actions, giving the LLM context on the computer's current state and allowing it to autonomously fulfill the user's initial request. And this creates a continual feedback loop. So next, let's look at the initial concept which Rehberger had in this attack. Well, ultimately, Sonnet is ingesting data into its context via screenshots, which could be controlled by attackers, and it's then performing actions. This makes it vulnerable to indirect prompt injection, which is a topic we have covered extensively on this podcast. Concerningly, Sonnet has near full access to the target's computer in its current beta release state, making it theoretically possible to completely compromise the controlled machine. Johan Rehberger wanted to see if it was possible to gain full remote access to this computer by getting Claude to download and run a binary file which he created. He configured this implant file to connect back to a Sliver command and control server when executed, giving him access to perform arbitrary commands via the C2 framework. Finally, Rehberger uploaded the implant to an internet-accessible server which he owned, and he set up a web page containing a link to this file. The attack was primed. So, for the prompt injection, as an initial test, Rehberger created an indirect prompt injection that directed Claude to run a simple bash command. Rehberger pasted the URL for the site into Claude, causing it to navigate to the website and perform the actions on the page with no further prompting. This prompt injection worked. Next, the security researcher attempted to modify the bash command, convincing Claude to execute wget or curl and download the implant from his server. Unfortunately, Claude complained in response, highlighting the risks of downloading untrusted files from the internet. So, refinement. Rehberger took a step back and simplified his prompt injection to mirror the techniques used in traditional social engineering attacks. Since LLMs have been trained on human language, doing this often makes prompt injection attacks more effective. As shown in the screenshot below, Claude immediately complied and clicked on the link, just like an unsuspecting user. The scary part. Claude computer use is designed to run with a feedback loop, minimizing the need for human intervention. But in this scenario, the feedback loop made Rehberger's prompt injection even easier to pull off. So, in his own words, at first, Claude couldn't find the binary in the download folder. So, step one, it decided to actually run a bash command to search for the file, and it found the file. Number two, it modified the permissions using chmod +x which is a Linux utility that allows you to make files executable. And finally, it ran this binary all by itself. This is a classic example of AI trying to be helpful, but making itself more vulnerable to abuse in the process. So Claude automatically executed the file, connecting back to the Sliver server and allowing Rayburger to execute arbitrary commands on the target's computer. That's fascinating. Now let's take a look at how we can mitigate this type of attack in the future. Since Claude takes actions based on content found on websites, there is no simple way to mitigate this type of attack. The best answer would be implementing human in the loop, or HITL, putting gated approval in place every time the large language model is about to take action. If HITL was built into computer use, the tool would need continual supervision, defeating its purpose of intelligently automating online tasks. I wrote about the shortcomings of this in my white paper earlier this year, and it is intriguing to see some of my hypotheses playing out in the real world. So, final thoughts, the future. Overall, while Claude computer use is a fantastic technology, it has serious shortcomings. It can be prompt injected with extreme ease, leading to the potentially devastating impact of facilitating arbitrary code execution. If this tool is used to control people's actual host computers in the future, I believe we will see organized crime groups and nation states leveraging indirect prompt injection as the new phishing email. A user will be completely compromised by asking their AI the wrong thing, which comes back to the initial question, should we really be letting AI control our computers? And that's a wrap. Thank you so much, everybody, for listening. I really hope you enjoyed this episode. Another one will be coming out in the coming weeks, and stay tuned for more content.